Hello dear students, today is the second lecture for probability theory subject. As we mentioned in the last lecture that the sets have many operations such as union and intersection. As a result to these operations we have the following theorems. The first theorem is Demorgan's law. A union B complement equal A complement intersection B complement. For example, let S equal 1, 2, 3, 4, 5, 6 and A equal 1 and 2, B equal 2 and 4 and 6. We require the following: A union B, A intersection B, A complement, B complement, A union B complement, A complement intersection B complement. The second theorem is distributive law. Distributive law said that A union B intersection C equal A union B intersection A union C, A intersection B union C equal A intersection B union A intersection C. The next topic is functions. We often need the concept of functions in probability. A function f is a rule that takes an input from a specific set called the domain and produces an output from another set called codomain. Thus, a function maps elements from the domain set to elements in the codomain with the property that each input is mapped to exactly one output. For a function f, if x is an element in the domain, then the function value is shown by f of x. If A is the domain and B is the codomain for the function f, we use the following notation. The output of a function A and B always belongs to the codomain B. However, not all values in the codomain are always covered by the function. In the above example, the function value is always positive number. We define the range of a function as a set containing all possible values of f of x. Thus, the range of the function is always a subset of its codomain. For the above function, the range of f is given by the following formula. The next topic is random experiments. Before rolling a die, you don't know the result. This is an example of a random experiment. In particular, a random experiment is a process by which we observe something uncertain. After the experiment, the result of the random experiment is known. An outcome is the result of random experiment. The set of all possible outcomes is called the sample space. Thus, in the context of a random experiment, the sample space is our universal set. Here are some examples of random experiments and their sample spaces. The random experiment of toss a coin, the sample space is head and tail, or as we usually write H and T. The second example is for a random experiment is rolling a die and the sample space is 1 and 2 and 3 and 4 and 5 and 6. The third example is observe the number of iPhones sold by Apple Store in Boston in 2015. The sample space is 0, 1 and 2 and 3 and so on. Finally, observe the number of goals in the score match. The sample space is 0 and 1 and 2 and 3 and so on. When we repeat a random experiment several times, we call each one of them as a trial. Thus, a trial is a particular performance of a random experiment. In the example of tossing a coin, each trial will result in either head or tail. Note that the sample space is defined based on how you define your random experiment. Our goal is to assign probability to a certain event. For example, suppose that we would like to know the probability that the outcome of rolling a fair die is an even number. In this case, our event is the set E equal 2 and 4 and 6. If the result of our random experiment belongs to the set E, we say that the event E has occurred. Thus, an event is a collection of possible outcomes. In other words, an event is a subset of sample. An event is a subset of sample space to which we assign a probability. Although we have not yet discussed how to find the probability of an event, we might be able to guess that the probability of 2 and 4 and 6 is 50%, which is the same as half in the probability theory convention. So we have three important definitions. The first definition is the outcome. It is a result of a random experiment. Sample space, it is the set of all possible outcomes. Event, it is a subset of the sample space. The sample space, it is the set of all possible outcomes. For rolling die, it is 1, 2 and 3 and 4 and 5 and 6. Partition is collectively exhaustive and mutually exclusive set of events B1, B2 until Bn. It is a partition if B1 union B2 union B3 union until Bn equal sample space or S or sigma, and Bi intersection Bj equal phi and I not equal j. Summary of random experiment. We have to know a review on set theory and random experiments and its examples such as rolling a die or tossing a coin. The outcomes. An outcome is a result of random experiment for such as rolling a die and rolling a die 3 times. Sample space, the set of all possible outcomes. The sample space for rolling a die is 1, 2, 3, 4, 5, 6. Events. An event is a collection of possible outcomes. An event is a subset of S. And the events for rolling a die such as E1, 1 and 2, E2, 4 and so on. We also say that an event A has occurred if the outcome of the experiment is an element of S. The probability of event A, we assign a probability measure B of A to an event A. This is a value between 0 and 1 that shows how likely the event is. If probability of A is close to 0, it is very unlikely that the event A occurs. On the other hand, if probability A is close to 1, A is very likely to occur. The main subject of probability theory is to develop tools and techniques to calculate probabilities of different events. Probability theory is based on some axioms that act as the foundation for the theory. So let us state and explain these axioms. Thank you.